Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to teach you how to calculate the potential difference between 2 points in a simple DC circuit. So what we're looking at here, we've got this, again, very simple DC circuit, 3 batteries, 3 resistors, and what we're going to do here is we're going to try to calculate the potential difference between this point, which I've labeled A, and this point, which I've labeled B. Now, you'll notice that we've got resistors in the circuit, and there's going to be voltage changes across the resistors by an amount IR, by Ohm's law. So the first thing we probably should do here is calculate the current in the circuit, because we're going to need it to calculate voltage changes here, here, and here. Now, as I kind of glance this circuit over, you notice I've got this 24 volt voltage here, which is tending to produce clockwise current as defined by positive charge carriers. And we've got this 6 volt and this 12 volt battery, both oriented in such a way that they would produce counterclockwise current. Well, it looks to me like the 24 volts going to win. I'm going to go ahead and assume that we've got a current in this direction. I'm going to label it I. And again, that current would be the same all through this system. And now what I'm going to do is just use a Kirchhoff's loop equation to calculate the current. So I'm going to pick a location. I'm going to start maybe right here. And I'm just going to go clockwise through this system, taking into account all the potential differences. So as we start here, and again, I always imagine like a little ladybug or something walking around the circuit here. My little ladybug walks, jumps across this voltage here. That's going to be an increase in potential by 24 volts. I'm going to go ahead and put NCU for note consistent units. That's a 24 volt potential, but I'm going to leave the voltage symbol off of it. All right, now my ladybug, when she drops or jumps across this resistor, that's going to be a drop in potential by an amount IR. I'm going to put minus 5I for that. And again, there's my I, there's my R in ohms. Again, that's a drop in potential because as we move left to right, we're moving towards lower potential. Remember, current always goes from higher to lower potential in a circuit. When you define your current direction as the current direction, assuming positive charge carriers. So as our ladybug continues around this circuit here, here's another jump across a resistor. That's going to change in potential by an amount 3I. Again, it will be another drop. Ladybug then jumps across the battery here. Is going to drop by 6 volts in potential. This jump across the resistor is going to drop the voltage by 8I. Again, in Ohm's law, that's an IR term. And then when the ladybug jumps across this battery, the ladybug will drop in potential by 12 volts. Ladybug is now back where it started, so we're going to have minus 12 volts equals 0. And the equals 0 is when we're back to where we started. So the first thing we need to do is calculate a current. I'm going to go ahead and just do that. If I could, though. If I'm going to leave the voltage units off here and here, I should leave them off here. If you are going to leave the units off, you might as well leave them off everywhere. Oops. All right, so we got 24 minus 5I minus 3I minus 6 volts minus 8I minus 12 volts equals 0. So if you go ahead and solve this for I get a value of 0.375 amps. All right. The next part of this is going to be to figure out from that the potential differences at A and B. Now what I like to do, you don't have to do this, but what I like to do is I like to set a datum here. I'm going to actually put a ground symbol right here. What I like about the ground symbol too, it couldn't mean it anymore literally. Typically a ground symbol means that a circuit is actually connected to Earth. What this does is it basically puts a datum. And what I've done is I've defined this part of the circuit as having 0 potential. Now the reason why I chose this part of the circuit, well, because I know that's going to be the lowest potential because we're on the bottom side of that 24 volt potential. You can define anywhere you want to have a 0 potential. Now, if you've seen my videos dealing with voltage and current, you know that I like to color code my potentials. So I'm going to go ahead and do that before I do anything else in this problem. So I've now set the potential here equal to 0. And this is all at 0 potential because this is all conducting material. Now we're going to have a change in potential here. I'm going to color code this new potential red. That's going to be good up to this point. Let's see. think I'll use orange for the next one. There's a voltage across the resistor, That's going to change our voltage to some other value. We're going to get a voltage drop across this resistor, so we're going to get another change in potential. I think I'll call this one yellow, this voltage, and that's going to be good anywhere along here, again, because of this is all conducting material, so that's all going to be at the same potential. We're going to get a voltage drop across the battery. So green here is another potential. All right, we're going to get a voltage drop across this 8 ohm resistor. I think I'll call that blue. Again, this is all one voltage, and now we're back to where we started. And what I'm going to do now is I'm just going to go through and I'm actually going to calculate voltage values for all these different color voltages. Now, the datum here means that the voltage here is 0. When we put a datum here, that's basically, we are setting that voltage to 0. I could have put that datum, or I could have put this ground anywhere in the circuit I wanted, and that would set that voltage to 0. Now I'm just going to go around this loop now clockwise here and calculate values for the voltage. So this is a 0 volt potential. When we go across this battery, we're increasing by 24 volts. So that's going to make this red voltage here 24 volts. Go ahead and write that. 24 volts. Now, when we go from red to orange, we're dropping in potential by an amount IR, and the I is 0.375 amps. So the orange potential, I'm going to put potential orange here, is going to equal the red potential, which is 24 volts, minus 0.375 amps times this 5 ohm resistor. And I get a value here when I do this of 22.125 volts. So our red potential here, I'll label it, is 22.125 volts. All right. Now, when we go across here, we are going to drop in potential by an amount 3 times the current. So let me write this. Our yellow potential, I'll put potential yellow here, is going to equal our orange potential. And we're going to drop by an amount, 0.375 amps times 3 ohms. And again, our orange potential here is the 22.15, and I get a value of 21 volts for this. All right, so we are at potential yellow, 21 volts. All right, now, when we go from yellow to green, we are dropping the potential by 6 volts. So that's going to make our green potential here, I'll put potential of green here, 15 volts. When we go across this resistor, we're going to drop in potential by an amount of 8I. I'll just write a little equation for that. So our blue potential, I'll put potential blue, is going to equal potential of the green minus 0.375 amps times 8 ohms. And when we do that, I get a value of 12 volts. So our blue potential here is 12 volts. And you'll notice that when we go from blue to black, we're dropping by 12, and you notice we're back to 0. And that's a required part of this. That means we're probably on the right track here, because I use the fact that the potential differences in any closed loop have to add to 0. All right, so now we got values for our red potential. I should go ahead and label that. Whoops, do a better job than that. So our red potential value is going to be 24 volts. Our orange potential here, 22.15 volts. And again, I'll put potential of orange here. Our yellow potential is 21 volts. Green potential, 15 volts. Blue potential, 12 volts. Now, one thing I'd like to comment about, again, these numbers are all dictated by where you put your 0. Just for the sake of example, had I put maybe the ground here, the blue potential would be 0. The black potential would be minus 12, and so forth. Now, the only thing that ever matters are differences in potential anyway. I'm going to go ahead now and calculate the potential difference between A and B. So if I start at potential A, and I move over to here, we're going up by 6 volts. When we go across this resistor, we're going to increase in potential by 3I1. 3I, there's only one current in here, and that current is, where'd it go? 0.375 amps, and we're now at potential B. So if I go ahead and run a value for that, I get 7.125 volts. So that's the potential difference between points A and B in this circuit. Now, when I calculated, I just kind of imagined walking over here and took into account all the potential differences, but I could have also just done this. I could have taken the 22.125 volts and subtracted the potential I'm at, which is 15 volts, and got the 7.125 volts. So to find the potential difference between 2 points in a circuit, you take into account all the batteries, and you make sure and take into account any currents you're going to need if there's any resistors between the 2 points you're looking at. Now in my example, going from A to B, there's a resistor here, so if I imagine going in this direction, I'd need that current. There's 2 resistors here and here, so if I imagine going in the other direction, I would need the currents here and here. Now in this example, this is a single current example, so those end up being the same currents, but in more complex circuits they could be different ones. And then I just basically color code my potentials, walk through the circuit, and calculate values for the potentials at each spot. And once you have the values of the potential for each spot in the circuit, you can just take the potential of one point, subtract the potential from the other, and there's the potential difference between the 2 points. So I hope this video helps demonstrate how to find potential difference in a simple circuit. Have a great day.